Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 22nd. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. Remnants of a little gale up in the northern Gulf of Alaska, and some weak fetch towards the dateline, but really, otherwise, nothing of interest occurring. We start this week's tour, as usual, looking at upper level winds. Jet stream level winds up about 30,000 feet. These winds, when in the proper configuration, help support the formation of storms and then also help direct their path once they do form. Currently, we have a decent looking area of 140 knot winds just off of Japan. The jet stream is fairly consolidated here, but to the east, it's a bit fragmented. Winds are weak, so that is not unexpected. And then continuing on, what's left of the main flow of the jet is pushing into California. The only area really supportive of gale development would be this little pocket here, a little bit of a trough trying to form. And you notice there's also a little bit of a trough here trying to push into the Washington state area, but of no real interest. Winds are weak, not enough to support barely low pressure, much less gale development. Let's put this into motion. Can we roll this out into Monday? Notice winds spread over the dateline and stronger now, again in the 140 knot range, but covering a larger area. This pattern continues on for a bit until we get into Tuesday, and then winds start picking up even more. We're into nearly 170 knots by Wednesday, and building there's 170, almost 180 knot winds. A bit of a trough forming here, just off the Kurill Islands, this on Wednesday night, and another trough, a bit of a pinched off trough, also north of Hawaii, but not super supportive of gale development because there's no winds down in the apex of the trough, the bottom of the trough here. It is this motion in the jet stream that helps set up a counterclockwise circulation. That is the essence of what makes low pressure. But this up in the upper levels of the atmosphere works its way down towards the surface, helps support gale formation. This area, not so supportive. This maybe more so. Anyway, roll it out. The winds continue pretty good. Notice the jet is split here over Asia. That's a bit troubling. That is probably a sign of what is to come. So this is a good consolidated patch here. That trough continues. We're into Thursday now. We'll just roll this out. Well, notice winds there, 190 knots by Friday. Good support for gale development right in here, but that's about it. Notice the jet very split over the U.S. West Coast at this point in time. High pressure in control there. Roll this out Friday into Saturday. Then the jet starts falling apart. Wind energy or energy levels drop off. The split that was over Asia starts working its way into the West Pacific, and things just aren't looking so good from that point on. Wind levels or speeds drop off considerably, and there we are. By 180 hours out, we're into Sunday night, a week out, the 29th of March. Almost a split jet stream flow. Wind levels low, no troughs of interest, and not a whole lot going on. So a little bit maybe midweek, and that seems to be the best of it from the jet stream level. Let's go down on the surface and take a look. So this chart, surface level pressure, here we go, 996 millibars, low pressure here, higher pressure over towards Japan, 1,016 millibars, and winds, a little patch of 30 knot winds there, 25 knot winds and another little low up here in the Gulf, but nothing that is at all inspirational or suggest any significant wave development. Anyway, this low starts working its way into the Gulf on Monday and just never really gets organized even into Tuesday, and still just 25 knot winds. That's not really enough. You need at least 30, preferably 35 knot winds to get a 13-second period swell. It just doesn't look to be in the cards. There's a little patch there on Wednesday, but I mean, these are more like little fleeting areas of fetch, nothing significant. Now, this next gale, and this is in that stronger trough, supported by the stronger trough we saw in the upper level charts. On Wednesday, little patch of 40 knot winds, 30 knot winds over a larger area, looking somewhat interesting. 40 knot winds, and it works its way to the dateline on Thursday or so, Thursday night, and continues the whole way almost into the Gulf, and then it too starts falling apart by Saturday, and that's kind of the end of it. We'll roll this out, and then high pressure, 1028 millibars, takes over the dateline, and that looks like the best it has to offer. Let's go take a look at the significant wave height chart. So here we go, significant wave heights for the North Pacific Ocean. We're actually going back in time, Tuesday of last week. A little gale tried to develop here over the northern dateline region. Little area of 20-foot seas Tuesday night. And as we see 20-foot seas continued south into about Thursday morning. Relative to Hawaii, this is about the, let's say, the 340-degree path. Swell from that system is hitting Hawaii as of right now, just starting to, and will continue into Monday. But then here this gets a little more interesting. Additional fetch moved in from the west. We got another area of 20-foot seas by, let's say, Friday morning, 22-foot seas. Relative to Northern California, that's about the 282-degree track, and relative to Southern California, about the 288-degree track. And that worked its way east into, let's say, almost Saturday morning. Again, about the 284-degree track relative to Northern California, and the that's 87, so about the 290-degree track to Southern California. So a little bit of swell is expected on Monday, I believe it is, from this system. So here we are, Sunday, current right now, and basically the fetch that we saw, or the seas that we saw early in this presentation, were leftovers from that system. That all fades out. Energy tries to get going here in the Gulf, as we saw on the surface level pressure charts, but there you go, a little patch of 20-foot seas maybe on Wednesday morning. Relative to Northern California, what is that, the 296-degree track, and probably too far north to be of any interest to Southern California, and too far east to be of any interest to Hawaii, and not aimed at the Hawaiian Islands. So sideband swell from all this is likely for the Hawaiian Islands, probably in the 10-11 second period range. Anyway, so then there's the larger gale pushing off Japan by Wednesday night. 24-foot seas relative to Hawaii on about the 304-degree track. We'll just leave that right there. And let's see, that's 20, 22, 24, probably 25-foot, 26-foot seas on the 312-degree track by, let's say, Friday, and then it starts fading out, starts getting torn apart, not good support from the jet. And then whatever's left really may be good for some little energy for Northern California on about the, what is that, the 290-degree track or so, 289, and then that fades out, and then there we go, that's the end of it. So a little bit for the North Pacific, but nothing too interesting. Hawaii probably best positioned to get that second swell from the second storm if it forms. Now the other area of interest, South Pacific, Super Typhoon Pam. Falling south. We're back Friday a week ago. We'll just put this into motion. Falls south, over the northern tip of New Zealand there, and then it gets caught up in the jet stream on about Monday night of last week and starts developing some fetch and seas. We're talking a tiny little area, 32-foot seas or so, relative to Hawaii. What is that, about the 193-degree track to Hawaii, but the winds here were actually going this way, so at best it's perpendicular to the Great Circle tracks to Hawaii, but still some swell is expected from that. Relative to Northern California, what's that, about the 215-degree track, and unshadowed by Tahiti, and the same for Southern California, about the 218-degree track. And it sort of festered there for a little bit, tried to reorganize again on Tuesday night. Again, not really moving a whole lot. 212 or 13 degrees to Northern California, and Southern California about 214, 15. Starting to get shadowed relative to Tahiti, though. And again, perpendicular to the tracks to Hawaii on about the say about the 190-degree track or so. And then it started moving east, we see, and faded out. But then on Friday night, the system got re-energized, additional fetch, and this was fetch. If you saw the wind charts, it was all coming out of the south, aimed much better to the north. So this is past Hawaii, nothing really aimed at Hawaii, and on a very southerly track for Northern California. This about 190 and about 193 relative to Southern California, and built nearly 40-foot seas. Now let's see how that fares. There's the 180 track, so that's about 184 to Northern California, and about the 186 27 to Southern California, but again, more focused over in this direction relative to Costa Rica. See, look, notice the arrows are pointed right up the Great Circle paths to Costa Rica, and even for that matter, Peru, much better, and also down into Chile as well. Northern Chile would do okay, and a second pulse as well into nearly Sunday morning, and then it faded out, and not a whole lot expected behind that. So southern hemi-swell also on the charts, bound for Hawaii and also the U.S. West Coast. Be interesting to see how much actually materializes. Next, we look at the Southern Oscillation Index. So we're looking at long-term weather indicators now, specifically the MJO, Madden-Julian Oscillation, and El Nino, La Nina. Difference in pressure between Darwin, Australia and Tahiti. Negative numbers. A long run of negative numbers represents at least the active phase in the Madden-Julian Oscillation, and beyond that, perhaps the formation of El Nino. We've been on a good run. It started just here on about the 5th of March. Nice run of negative numbers, getting deeply negative around the 17th in association with a strong pulse of the Madden-Julian Oscillation and a big westerly wind burst in the West Pacific. We'll get into that in a minute. But currently, the daily number, minus 6.7, starting to rise. Things looking a little weaker there. The 30-day average, once again, notice it went from neutral or zero, now it's down to almost minus 10 or minus 9.84, and the 90-day running average, about where it's been hanging for months and months now. The average was about 0.8. It went up a little bit here. Now it's minus 7.48 and probably about bottomed out. Here is the 30-day SOI average over time, going back to January 2013, basically La Nina. Big negative drop in early of last year. Major push of the MJO, major westerly wind burst, major Kelvin wave produced. We thought we were in a big El Nino, but then things sort of moderated a bit. But then come July, we dropped into this steady, about a minus 8 or 7 or so negative SOI range. We've had a little upward tick here in the February timeframe, and now we're again back into negative numbers. Looking to see what's going to happen out here. The thought is we're probably going to get a repeat of what we had in 2014. Hard to say, but you sort of get a perspective where we are in the past year or so compared to several years prior. Really, it was all up in positive numbers since about February of 2010. So it's been La Nina for a long time. At least we're on the right side of the curve. The bottom side of this line is where you want to be to get support for El Nino development. So that's where we are. Next, we look at wind anomalies. This is differences in wind direction and speed for all this area of the globe for this time of year. So here we go. Philippines here, Australia here, dateline here. Westerly anomalies, not nearly as strong as they were, but still westerly anomalies of any kind are good. That means a relaxation of trade winds in that area, and that helps support Kelvin wave development. That is, warm water in this area, just a couple of degrees either side of the equator, will fall to depth when trades die or reverse themselves, create a pocket of warm water. They'll travel the whole way across the equatorial Pacific, start gurgling up off the Galapagos 3 months later, form a warm water pool around the Galapagos, and that is the hallmark of El Nino. So that is why we are monitoring this area, looking for signs that El Nino is developing. Also, these westerly winds, when they occur, help fuel the jet stream and in the North Pacific and help support storm development. So these westerly winds are associated with the consolidation of the jet stream and increased wind speeds in the jet stream that theoretically should be helping storm and gale development. Not so much so right now. The thought is it's kind of late in the season, and even though the winds were raging here a couple of weeks ago, the temperature differential in the atmosphere was not enough to really support gale development. Anyway, we look to the East Pacific. Neutral anomalies. Here's Mexico here, the Galapagos here. Not a whole lot going on there, but that doesn't matter. It is what we call the Kelvin wave generation area, from about 170 west to back here to about 135. So if you could draw a box right about here, this is the area you want to see the westerly anomalies, and that's what supports Kelvin wave development. Looking a week out, the end of the month, Still, light westerly anomalies, not much though. You notice they're definitely weakening. That suggests the MJO is weakening and the storm pattern should be weakening as well. The upper level model that we saw depicts the jet stream starting to split and getting weaker a week out. So all this fits together, it's cohesive, and makes sense. And again, in the East Pacific, not a whole lot going on. Pretty much neutral anomalies, a little pocket of easterly anomalies south of Mexico, but nothing of any real significance, just sort of randomness, if anything, a normal pattern. So we've seen this chart before. This is a great chart. This is the entire globe on one chart over time, and easterly, westerly wind anomalies depicted. So the far West Pacific would be about here. The far East Pacific would be about here. The reds are westerly anomalies. The blues are easterly anomalies. We go back to February 20th. Now note, prior to February, there was westerly wind anomalies the whole way through January into February. Not really strong, but just moderate. And then come about the end of February, things started picking up. And notice this, an extremely strong pocket of westerly winds. Full out, I mean, these weren't anomalies. This is an anomaly chart, but the reality was these winds were 20, 25 knot plus, full-on reversal of trades in the Kelvin, right in the middle of the Kelvin Wave generation area. And there was plenty of warm water at the surface area. This was great to support Kelvin Wave development. And then even a little bit more into the middle of March. And now here we are about the 22nd of March, still westerly anomalies and still forecast to be light westerly anomalies moving to the dateline through the end of the month. So the expectation is that a significant Kelvin Wave event is underway, that a large Kelvin wave will be generated. It's not quite there yet in terms of actually being depicted, but given this amount of wind, it has to materialize. Next, we look at the forecast, see what's going to go long term. This the outgoing long wave radiation forecast from the statistic model. Blues are what we are considered the active phase of the MJO. Reds, the inactive phase. This reduced sunlight reflection off the ocean surface, presumably due to clouds, presumably due to the active phase of the MJO. This, a lot of reflection off the ocean surface due to high pressure, due to the inactive phase. Currently, the active phase fading, expected to dissipate south of Hawaii about 2 weeks out. And per the statistic model, the inactive phase is to come roaring in. Now, it's interesting. The dynamic model depicts a totally different scenario. The inactive phase dies. Notice the active phase dies as well. And then we just go into a dead neutral pattern, if not perhaps a weak active phase trying to redevelop and work its way east. So it'll be interesting to see which model 2 weeks out wins the bet, or maybe it'll be a hybrid of both. The upper level model, which sort of races ahead, it's almost an early predictor. So the oranges and yellows are no support for rain, the inactive phase of the MJO. Greens are the active phase of the MJO and more support for precipitation. This up at the jet stream level. This is a 40-day model. So it depicts that the active phase is already working its way into Central America, and the inactive phase is already starting to push into the West Pacific. It's supposed to do its cycle and be the whole way across the Pacific by about the 16th of April, but remember, the reality is this is at least a week ahead of reality, and then a new active phase starts building, kind of weak, about the same time over in the far West Pacific, builds as it works its way east, and then a new inactive phase behind that into, let's say, early May. The issue here is we're late in the season. The MJO starts having less and less of an influence on the atmosphere. It does its thing best in the fall and winter months, but still, something to watch, something to see, and sort of give us a clue as to what's coming for the future. Next indicator we look at is sea surface temperature anomalies. That is, differences from normal for this time of year for any of these locations on the planet. Notice, as usual, has been the norm for a year now, much warmer than normal water along the entire U.S. West Coast, cooler water here north of Hawaii and the West Pacific. This is sort of the signature of the active phase of the PDO, or the phase that supports the formation of El Nino. Now again, the atmosphere is a big boat. It takes a long time to turn. This started last year. About the first signs of it were last year at this time. It started getting really pronounced in the fall and late summer time frame, and it's still holding pretty well. The question is the PDO turning? It's a 15-year or more cycle. It's been in the negative phase for 15 years since the big El Nino of 97, 98. The thought is maybe it is starting to turn now. We'll see. It's way too early to know. What we're more interested in is warm water on the equator. Typical El Nino monitoring area, right along in here. Actually, they say 120 to 170 is the Nino 3.4 region, just a couple degrees either side of the equator. But really, if it's a real El Nino, you'll see piles of warm water all up along the South American coast or the Central American coast. That's not the case. But in the past week, there was cool anomalies all along here. That has stopped. Warm water is starting to build again. We suspect that this might be early response to a building Kelvin wave working its way across the equatorial Pacific. Warm water here. This is the classic Modoki El Nino signature. It's El Nino, but not really, because it's displaced more between, let's say, south of Hawaii and the central Pacific, they say. So, and Modoki El Nino doesn't do a whole lot for supporting precipitation in the U.S. West Coast, and typically doesn't do a whole lot to support storm development in the winter months. A little bit, perhaps, but this one, not a whole lot. Winter, as far as we can see, is effectively over. Once this phase of the MJO wraps up in the next week or two, then that's it. Pretty much you can put a bow on winter and call it a done deal unless some miracle occurs. Anyway, so we're looking for the formation of El Nino. Pockets of cool water, pockets of warm water. Right now, again, this all just looks like a typical Modoki El Nino pattern. Nothing of real interest. This cool pocket here was here last year. It kind of worked its way up north of the equator at times and then went back south. Here it is again. Again, we suspect this is somehow related to the Modoki El Nino, but that's not guaranteed at all. Here's another way to look at surface temperature anomalies. Here's actual temperatures, actual wind speeds. Notice real westerly winds still occurring on the surface in the Kelvin wave generation area, basically that area right in there. So that's a good sign. It's not just anomalies. Here's the anomalies now. Notice a large area of anomalies over in the Kelvin wave generation area. 1.5 degree temperature anomalies here. Lots of opportunity for warm water to be pushed to depth. And then over here, this was actually much cooler 2 weeks ago. It was negative temperatures, about a minus a half a degree. Now it's all, let's say basically normal and actually warming up again to almost, let's say about 110 west. So this is all a good sign too. Not particularly strong warming, but at least it's going in the right direction. But it is the subsurface view that's important. Okay, so this is the West Pacific, this is the East Pacific, this is the equator, and we're looking at depth, a profile on the equator. Of course, these are buoys, and the sensors on the buoy's anchor line used to gather the measurements to get the subsurface water profile temperature view here. But it is the anomalies, the differences from normal, and here's what we see. 4+ degree anomalies right here, and building in coverage in area. You can actually see warm water falling to depth here. This from the westerly anomalies that have been blowing for 2 months. This started being just from anomalies from January into February, and then February the strong westerly wind burst started, and a full-on westerly reversal of trades. More warm water falling south. This pocket is building in coverage and will start working, and is in fact working its way east. This is a Kelvin wave, a good size one, very similar to one that occurred last year, same time. This may be a little bit later in the game, but still a significant Kelvin wave event, a significant westerly wind burst event. It will work its way, and by about May it should start arriving along the Galapagos, and by June the warm water from the very strongest of the winds should start gurgling up here. So this is going to be something to watch in the next 2 months. If, in fact, an El Nino were to form, we're not saying it is. This thing happened last year. We ended up with a Modoki El Nino, but it looks like, by all rights, it should be a very strong El Nino. But because last year didn't do a whole lot, the atmosphere has been in a La Nina pattern or biased La Nina for the better part of 15 years now. So it's going to take a while for it to wake up and respond. But clearly the thought is that things have changed, the tide has turned, the PDO has changed is one way numerically to view it, but the fact that there are major westerly wind bursts 2 years in a row, major Kelvin wave development, that surely is a sign that something is changing. And here's another view, basically a modeled view of the same thing. This one says 5-degree anomalies, and count them, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 5 to 6 degree anomalies, probably let's say barely 5 right in here. But still, large Kelvin wave. Notice, cool water here, just starting, still gurgling up. Basically, this warm water is coming in, just pushing any cool water up out of the way. These are these pockets that you see showing up around the Galapagos. And warm water not too far away. What is that? About 100 degree west, and the Galapagos is about 90, so right about here. And so the early little tiniest finger of warm water is just about to start reaching the Galapagos, say in another couple of weeks. And then there's much, much more. And look at that. You can actually see the warm water falling to depth. This pocket we expect to build over time over the next month and see water temperatures go up higher, probably a lot higher. And then all this, the water actually starts warming once it starts going further up into, starts getting in shallow water. The temperatures actually increase, or at least that's been the trend from our observations. So it'll be interesting to see how this plays out. But a significant warm Kelvin wave, we believe, is in flight, working its way towards the Galapagos. And here's another way of looking at it. West Pacific here, East Pacific here, going back in time. Last year, the major Kelvin wave that worked its way across the Pacific. And this one, in this image, let's see, so that is 2-degree anomalies in this view. This is all temperatures down 300 meters across the entire Pacific. So that was a major Kelvin wave. Upwelling phase of the Kelvin wave cycle in July of last year. Things cool off a little bit. Then 2 little mini Kelvin waves into the fall of last year. Another upwelling Kelvin wave event. And here we go. Here's the new Kelvin wave in development. Again, not as strong as last year's Kelvin wave. You can see the difference. But still very solid nonetheless, and still in development. Still warm water falling to depth. So this has a way to go before it matures. We would not be surprised to see it come close to the Kelvin wave of last year. And finally, the forecast from the CFSV2 model for the Nino 3.4 region. Water temperatures in the main area used for monitoring El Nino. Currently, water temperatures, the average, about 0.6 degrees, let's say 0.65 or so. Expected to slowly ramp up in July, about 1.25 degrees, which would definitely be El Nino if that were to occur. But El Nino really doesn't do its thing till about the December time frame. This model is suggesting about a 1.7 or 1.75 degree average temperature for the Nino 3.4 region. If that were to occur, that would be a pretty solid El Nino, not like off the charts or anything, but a decent El Nino. We don't know that that's necessarily going to happen. The model said the same thing last year. It was saying temperatures up into the 2.2, 2.5 range, somewhere ridiculous like that. And in the end, look what we got. It just sort of muddled along. We wouldn't be surprised if it muddles along next year too, but maybe a little bit stronger because the atmosphere will have another year of momentum behind it if the PDO has changed. So we'll see. But the train seems to have left the station. The boat is turning. We're throwing all the metaphors we got at it here. But basically, we believe the atmosphere is turning to a more favorable long-term pattern, and not just for a year or two, but maybe for the next 15 years. If that were to happen, then we'd be in for a good long run of maybe multiple El Ninos over the long haul. But for now, we're suspecting just a Modoki El Nino pattern for the next 2 to 3 years, and then somewhere in the middle of that, perhaps a real legit El Nino. At least we're on the right side of the curve. So for now, small swell, already starting to hit Hawaii, working its way towards the U.S. West Coast for the early part of this week. Perhaps a little bit more energy behind that. Nothing dramatic. Southern hemiswell also in the water, working its way north from the extratropical remnants of what was Super Typhoon Pam. So swells from both directions in the water and on their way. Long-term pattern, looks like the PDO is changing. Our Modoki El Nino continues. Warm water in flight. The MJO has done a good job of changing or full reversal of winds in the Kelvin Wave generation area. So good things to look forward to as we get coming out of the spring unpredictability barrier by about May into June-ish time frame. Big Kelvin wave supposed to hit. We'll see what happens, see if it gets any traction in the atmosphere or whether it just kind of does like it did last year. The thought was, though, net tropical activity should probably be up in the Eastern Pacific. But yeah, the jury is definitely out on what's going to happen next fall and next winter, but it won't be La Nina. That's our guess. Anyway, that's it for this week. Go get some waves. There's swell in the water. We'll do this again next week. Same time, same channel. Thanks.